Now we come towards the application of the Bernoulli's equation. First of all, it is applied in hydrostatics. So we consider a fluid, and if the speed of the fluid is 0, everywhere putting V1 will be V2 equal to 0. Bernoulli equation is written as P1 plus rho GH1 equal to P2 plus rho GH2, and V1 minus V2 is 0, which is similar form of the hydrostatics. So we have taken out, we have shifted P2 to left side and H, that is rho GH1 to right side. It will become P1 minus P2 is equal to rho GH2 minus H1. Now we come towards the velocity of efflux. In the velocity of efflux, we consider a cylinder containing water. There will be a hole at the upper portion and at the lower portion. At the lower portion, the pressure of liquid is more. So when the water will come out from the lower hole, its range will be more. And from the upper hole, if the water will come out, you will find its range will be less. So the velocity of efflux means the velocity with which the water is coming out of the holes. Now we come to the main context. Consider a tank filled with the liquid of density. The tank is filled till height h, where A1 is the cross-sectional area of the top surface of the tank and A2 is that of the hole at the bottom of the tank. V1 and V2 are the velocities at A1 and A2. P0 is atmospheric pressure. Then from Bernoulli's equation, P0 plus half rho V1 square plus rho GH will be equal to P0 plus half rho V2 square. And from equation of continuity, A1 V1 must be equal to A2 V2. That is the second equation. From two equations, we get a mathematical expression 1 minus A2 over A1 whole square into V2 square, that is equal to 2GH. And if we take the square root, it will become, that is, root 2GH. For this, the condition is that A2 is very less than A1. So we have V2 that is equal to root 2GH. So in the figure it is shown, rho is the density of liquid, H is the height of the liquid column, and A2 is the area from where the liquid will come out. The speed of liquid coming out through the hole at depth h below the free surface is same as that of a particle falling freely under gravity through the same height, and this is called the Torricelli theorem. The speed of liquid coming out is called the speed of efflux. Now we come to the Ventury tube. It is used to measure the flow speed of the liquid. When the fluid is flowing, we have to find the flow speed, that is the velocity of the flowing liquid. Consider liquid of density rho is flowing through a Ventury tube where A1 and A2 are the two cross sections having pressures P1 and P2. Suppose that the velocities are V1 and V2 and those points, thus from equation of continuity A1 V1 must be equal to A2 V2, and Bernoulli's theorem states that P1 plus half rho V1 square is equal to P2 plus half rho V2 square. That is what the second equation. So from this equation we will calculate the value of P1 minus P2, which is found to be half rho into V2 square minus V1 square. As the liquids are at different heights, A1 and A2, we have P1 minus P2 as rho GH. 2GH will be V2 square minus V1 square. If we know the values of A1 and A2, then solving equation number 1 and 4, we can find the rate of flow at those cross sections. So this is a repeated figure. V1 is the velocity at A1 and V2 is the velocity as shown in the figure, and P2A2, this is the force at the point where the flow is V2. Now, P1 is the pressure at the entering point, aspirator pump. In aspirator pump, when air is pressed inside the tube, it comes out rapidly so that pressure at A reduces, whereas the pressure at B is more. For this pressure difference, liquid rises till the barrel and sprayed with the expelled air. It is shown in the figure. Swing of a ball. When a spinning ball is thrown with a large speed, then layer of the air moving above the ball is accelerated, while the below it is retarded due to the spin of ball. Therefore, according to Bernoulli's theorem, as kinetic energy above is more than the kinetic energy below the ball, pressure above the ball is less than the pressure below the ball. So, a force is directed in the upward direction, which deflects the ball in upward direction. It is shown in the figure.